Hello, my name is Christine Baes. I'm an associate professor in the Department of Animal Biosciences at the University of Guelph, and I hold a Canada Research Chair in Livestock Genomics. It is my absolute pleasure to tell you a little bit about our research on genomic selection for fertility, health, and efficiency in dairy cattle. But before I begin, I'd like to thank the organizing committee for the opportunity to speak today, and especially Dan Lacroix for all of his hard work in making this event happen. Although my research encompasses many different projects and areas, for this presentation I'll be focusing on phenotypes, or the physical characteristics or performance of animals. And there are three types of phenotypes I'd like to cover today. The first is fertility phenotypes. And as many of you know, current fertility traits have low heritability and are heavily influenced by management. Traits like age at first service or interval from calving to first service, they might have more to do with the producer than the heifer or the cow. And these constitute what I consider to be fuzzy phenotypes because the genetic and environmental effects underlying them are indistinguishable. And it's a similar story for improving health phenotypes, in particular calf health traits. Finally, I'll speak about our current work on developing efficiency traits, whereby in this case, the cost of phenotyping is very expensive and the traits are complex. But research being done right here in Guelph is changing the way we breed animals in Canada, so it's a very exciting area. As I mentioned, improving fertility phenotypes is a key area of study, and here I'd like to give you just a quick tour of some traits that my team and I are currently working on. First up, we have Audrey Martin, who's looking at the potential to use size and position scores of reproductive tracts as a genetic selection tool. As you can see from work done by Young et al., cows can be grouped into three general types: those with a small reproductive tract encased by the pelvic bone, those with a mid-sized reproductive tract, and those with a large reproductive tract. Animals with a size and position score of 1 performed better than the two other groups, which could show that if this trait is heritable, the work could provide the industry with a quantitative trait for use in selection programs. Next up, we have Camilla Rosenberg and Dr. Dirkles Cardoso, who are looking at the potential use of activity monitor data for novel phenotypes. They defined a number of different traits collected using automated sensor technology, and one of those traits was mean estrus strength. The graph on this slide shows the proportional distribution of success at first insemination and the number of services per conception in relation to cow breeding value classes for mean estrus strength. As you can see, just under 60% of cows in the group with high breeding values for mean estrus strength required only 1 service to conceive. In contrast, Camilla and Dirkles found only 40% of cows in the low group required only 1 service, and the number of animals requiring 3 or more services in that group was higher. So sensor technology might provide additional information or even additional traits for fertility. Dr. Gerson Oliveira wanted to better understand the implications of not recording whether animals were on timed AI. In collaboration with Dr. Larry Schaefer, he designed a simulation which showed that if animals on timed AI protocols were not differentiated from those who showed heat without other management interference, approximately half of the potential genetic gain would be lost over 20 generations. This graph shows the results for calving to first service, with a control group shown with a solid red line, and simulated herds using only timed AI in the thick dotted line, with variations in between. For traits with a low heritability, a loss of 50% genetic gain is quite substantial. So this would be an important measurement to record for improvement of fertility traits. Colin Lynch took Gerson's work one step further, and he used real data to verify Gerson's results. With this data kindly provided by CanWest DHI, Colin analyzed millions of dairy comp records and deciphered which animals were on a timed AI protocol and which were bred with simple heat detection. Although the regression between the breeding values estimated for animals on timed AI and those on heat detection was indeed positive, as you can see from the graph here, there is a clear re-ranking of animals indicating that these should be recorded as different traits. And for the last bit on fertility, Dr. Baes C DaG he took a close look at the effect of inbreeding on fertility and production and found that for all traits analyzed, there were unfavorable implications of higher inbreeding coefficients. Baes' work represents a first step to associate regions of homozygosity with traits of interest and could be further developed to help understand what areas of the genome can be inbred and which ones should not be inbred. The next topic of my presentation is some work we have started on improving health traits. About 46% of Canadian herds are infected with Mycobacterium avium subspecies paratuberculosis, or otherwise known as Johne's disease, which is likely associated with Crohn's disease in humans. And this is the topic of Aisha Fong's master thesis. Johne's can be detected through a milk ELISA test, which detects the presence of MAP-specific antibodies in animals, but this test has a low sensitivity, so we can't detect it in early infections. And it has a long subclinical incubation period, which can last for years. Heritability of resistance to Johne's disease has been estimated at about 6%, and that means that it's probably a polygenic trait, but moving forward, we'll be doing work, we'll be following up on work done by Dr. Neil Caro, and Aisha will be looking closely at interleukin-10 receptor alpha in a gene-edited cell line. With regards to calf health, 15% of Holstein calves die between birth and 2 months of age. And currently this information doesn't flow into the genetic evaluation system, but the most common causes of death include respiratory diseases and scours. There is, however, no standardized mode or method of data collection for these traits. So Emma Hyland is currently working together with Dr. David Kelton and his team, as well as 14 farmers in the area, to set up methods and data pipelines for collection of this type of data, which will then be used to develop calf health traits for inclusion in the genetic evaluation system. Finally, PhD student Lucas Lopez is looking at data collected from activity monitors to better understand the genetic correlation of rumination with other health and efficiency traits. Working closely with Dr. Dan Tulpin, Lucas is planning on using advanced artificial intelligence and machine learning approaches to analyze this type of data. And the last section of my presentation is on feed efficiency, which is a really hot topic in today's dairy world, given that feed comprises about 50% of production costs for dairy producers. Now, a story about feed efficiency wouldn't be a good one if it didn't include mention of the large-scale applied research project currently still running here at Guelph. This efficient dairy genome project was spearheaded by Dr. Filippo Miglior and is now under the leadership of Drs. Flavio Schenkel and Paul Stothard. This was the first Canadian attempt at developing a database for the collection of feed efficiency and methane data. And as a direct result of this project and the national and international data made available through it, LactaNet will be able to publish official genetic evaluations for feed efficiency starting in April of 2021. Fortunately for us, we were able to secure further funding to continue this very important research and to further expand our database by another 14,000 animals with feed efficiency records and another 6,600 animals with methane records. The Resilient Dairy Genome Project will collate the research efforts of numerous dairy projects, both in and outside of Canada, and it aims to deliver novel calf health, Johne's, and fertility traits, which will then be integrated into a resiliency index for the benefit of the Canadian dairy industry by the end of 2023. Tying it all together, I'd just like to mention one final project that was funded through Dairy Cluster, in which Lucas Alcantara, Carrie Houlihan, Colin Lynch, and Dr. Gerson Oliveira worked to estimate both genetic and phenotypic correlations of all 67 traits currently collected by LactaNet. This provides the groundwork for a number of further simulation studies involving new technologies and strategies. And I realize that you can't see the names or information on this slide, but I'd just like to tell you that it took them 18 months to make this wonderful work of art, and I just think it's beautiful. In summary, I think I hope I've shown you that there's a huge potential to improve the number, the type, the quality, and the volume of phenotypes we currently collect, in particular with regards to fertility, health, and efficiency. We need to incorporate automated data recording, and we need to get a better sort of data flow from farm to the evaluation centers. Another thing I guess I've sort of taken up in my research program is that we need to constantly critically analyze the methods and the traits that we use. Novel methods should be implemented, such as genomic inbreeding, and we need to better account for management and environment. Finally, I think we should continue and increase collaboration. I've seen from a number of my research projects that the large-scale research efforts tie in results from multiple projects and also from multiple areas of study, such as veterinarians or ethologists or nutritionists. All of that information together is, of course, best because it best describes how our animals live and produce. So overall, there's always room for improvement, but we continue to do our best in our research and in our supervision of master's and PhD students, as well as postdoctoral research fellows. With that, I would like to really thank all of the sponsors and participating organizations in the research that I presented to you today. And of course, I would also like to thank very much my absolutely fantastic team that has made all of this possible. Thank you so much for your time, and it has been a pleasure. Have a wonderful day. Bye-bye.